All right, in this video, let's take a quick look at using operators, mathematical operators, and some compound assignments and see how we code those up. So I'm going to start out with a simple variable. We'll start with an integer. We'll call it age, and we'll give it an initial value, let's say 14. Now, if I want to increase that age by 2, I can add 2 to it, and I do that through the addition operator. So I could say age equals age plus 2, and now age should be 16. And we can prove that by doing a print of age, and I'll do Command R and run this, and sure enough, we now get 16. So this is how the addition operator works. Very logical, very much like you would think. Note that it is between the two things that it's operating on. So we have a variable here, and then we have a number here. Now, these don't have to be. This could be a number as well, like 5 plus 2. That would do the math right there, and we would end up with 7, which is what we see. This could also be age over here on the right, and we run that, and we get 19. Now, it doesn't matter order on addition, and that's the same with multiplication, but that's not true for subtraction and division. Swift just follows the same rules that would be true in basic arithmetic with respect to how the operators work. So let's try another one. Let's say for subtraction, I could say age minus 3, and if I run that, I end up with an 11, and that's how we would do subtraction. Multiplication, we can do that by doing a times. So here we're going to be 14 times 3, and let's see what we get there. Okay, 42, that looks good. That's the meaning of life. And then we can do division as well. I could divide by 3 and run this, and we'll see what we get. Here we get a number of 4. Now this is a little interesting because 14 divided by 3 doesn't go in evenly. And so because this is an integer, we end up with a truncated result. Now, if I said 14.0 here, the type inference would say this is a double, and now we should get a more accurate result here. So when we rerun that, sure enough, we get 4.66667, basically 4 2/3, which is correct. So that is basically operators. Now, compound assignments are something that you'll see, and they're basically what I can kind of refer to as syntactic sugar. They are just syntactically different, but they do the same thing. So for example, let's go back to this. Let's say age is 12, and I want to add 1 to my age. I'm a year older. So the one way to do that is to just say age equals age plus 1. And that's very logical, very normal, and very acceptable, and that's good. And so now age goes to 13. But the other way to do this is what's referred to as a compound assignment, and it's compound because what I can do is I can use this syntax here. What this is saying is the variable age is going to get modified because it's on the left-hand side of the equality, or gets the value of. Here's the plus. So it's going to add whatever is here, add 1, onto this variable. And so if we run this, we should also get 13. But we could put, for example, 10 here and hit it, and now we end up with 22 because we have added a 10 based on this compound assignment. And this also works for other operators as well. I could do this with the multiply, and I should end up with 120 when I run, and I do. So those are the basic operators. You can also put these together. So I could actually change the precedence. Let's say that I wanted to do 8 times 4 plus 3. Now, normally, if we look at that, we ended up with a number that says 35, and that's because 8 times 4 is 32 plus 3 is 35. But what if I really meant for this to be 8 times 7? So we can, again, basic arithmetic, handling precedence, we put our parentheses around the 4 plus 3, and now we have 56, which is 7 times 8. So we can use our parentheses as well. Also, just keep in mind these always need to be balanced, and we can always use our cursor to kind of highlight one from the other. But if you end up with an equation that has 4 open parens in it, you need 4 closing parens. And the way I typically do this is, let's suppose we did something like this. And let's do, let's see here. So we had something a little more complicated. When I compile this, since I don't get a compiler error, I know that I've balanced everything out. What I typically will do as my trick to see that I have it all balanced is I'll increment a counter in my head every time I open a paren, and every time I encounter a closed paren, I decrement it. And I want to end up at 0. So for example, right here is a 1, a 2, a 3, a 2, a 1, a 0. And so I know that I have a balanced set of parentheses for the equation that I'm writing. So this is simple arithmetic operators in Swift.